Assalamualaikum. My name is Muhammad Dini Azizi bin Muhammad Nozi. Right now I will present about theory of thin cylinder. When a thin wall tube cylinder is subject to internal pressure, the wall will form a hoop stress, longitudinal and radial stress. Certain characteristics such as thickness, diameter, and length must be specified. Since the hoop stress and longitudinal stresses are constant throughout the thickness of the material, and the radial stress is minimal comparison to the hoops. When internal pressure is applied to a cylinder, internal loads and stresses are produced in both the tangential and longitudinal direction. By cutting the cylinder longitudinally, internal normal force in the tangential or hoop direction can be obtained.
Hi, Assalamualaikum. My name is Muhammad bin Kamaruddin. My metric number is CD200105. I will present about my part, that is an observation. Firstly, I want to explain about the cylinder apparatus that allows students to perform experiment that examine stress and strain in a thin wall cylinder. It clearly shows the principal theories and analytical technique and provide effective practical support to studies. For this experiment, it has a two procedure. Means it has a two experiment. Experiment 1 is open end and experiment 2 is closed end. For open end means the cylinder has no axial load, so there is no direct axial stress. Another one is closed end. The cylinder has axial load, so there is direct axial stress. If an axial stress does exist, then it is uniform across the cylinder wall, no matter whether the cylinder is thin or thick. The stress may be found easily from equilibrium in the axial direction, aided by a free body view inside sectional elevation. Untuk open end experiment ni, pressure dia ada 6. It have a 6 pressure from 0.5 until 3.0, and for the gauge is 1 until 6. For closed end, it have only one pressure, iaitu 3.0, dan gauge dia sama seperti open end, iaitu 1 until 6. To get a result from this experiment, we should know how to use this apparatus. First, we need to tighten the lever and pump until it reach the pressure that we want. Sebagai contoh, sekiranya kita nak pressure tu 0.5, so kita akan pump alat tu sehingga jarum tu akan menunjuk pressure tu pada 0.5, dan setelah siap kita akan dapat result. Kita akan reset kembali pressure tu. So dekat situ akan mengambil masa sedikit lama untuk buang dia punya pressure, and ulang semula langkah yang sama untuk dapatkan setiap data yang dia kasih. And setelah after we complete the open end experiment, we go through to closed end experiment that have only one pressure, 3.0. Okay, I think that's all from me. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farhan bin Syasul Anwar. My metric number is DD2039, and today I am presenting calculation of thin cylinder. Okay, the first one is for the open and thin cylinder, and the data given is the first, Young modulus is equal to 69 multiply 10 power of 9, and Poisson ratio is 0.33, and pressure 3.0, thickness T 0.003, and the last one is diameter D equal to 0.08 meter. Okay, the first one we need to calculate the hoop stress. The formula is PD2T, and the answer we get is 40 Pascal. And the next one is hoop strain. The hoop strain is formula is 1 over E multiply the hoop stress, and the answer we get 5.8 multiply 10 power of negative 10. The next one, longitudinal stress. The formula is PD for T, and the answer we get is 20 Pascal. The last one for open-end thin cylinder is longitudinal strain, which is 1 over E multiply negative V Poisson ratio multiply the hoop stress. Okay, and the answer is negative 1.913 multiply 10 power of negative 10. Next, for the calculation for closed-end thin cylinder, the first one we need to calculate the hoop strain. The formula is 1 over E multiply the hoop stress minus Poisson ratio multiply longitudinal stress, and the answer we get is 4.841 multiply 10 power of negative 10. Next, the last one, longitudinal strain. The formula is 1 over E multiply longitudinal stress minus Poisson ratio multiply hoop stress, and the answer is 9.855 multiply 10 power of negative 10.
Assalamualaikum and a very good day. My name is Muhammad Arif bin Umar Ali. My matric card number CD 2082. So today I'm here to explain about the difference between open-end condition and closed-end condition in thin cylinder. So first let me explain about open-end condition. So in open-end condition, the cylinder has no axial load, so there is no direct axial stress. So as you can see in the picture here, in the open ends condition, the hand wheel is fully screwed in. This pushes the two pistons away from the cylinder end caps, so that there is no contact between them. Therefore, the axial force is transmitted from the pressurized oil into the frame rather than the cylinder. So for this open end condition, it has no constraints and have longitudinal component stress and will be zero. Unfortunately, there will be some strain in this condition due to the Poisson effect. Next, I will explain about closed-end condition in thin cylinder. So in closed-end condition, the cylinder has axial load, so there is direct axial stress. So as you can see in the picture, in this closed-end condition, the hand wheel is wound out. This allows the pistons to move outwards against the cylinder end caps, so that there is no contact with the frame. Therefore, the axial force is transmitted from the pressurized oil into the cylinder itself. Then for closed-end condition also, with constraining the ends, a longitudinal as well as circumferential stress will be imposed upon the cylinder. That's all from me, and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fadil bin Sifaat, number matric DD200-108. So today I'm gonna share about discussion for question B. So the question is, which case experience unaxial state of stress and which case experience biaxial state of stress? So from these two cases, we got to know that there is open end and closed end condition. So for open end condition, it will experience an unaxial state of stress, while closed end will experience a biaxial state of stress. So from this experiment is to investigate the stress and strain in a thin cylinder. So the thin cylinder is closed at one end, a movable piston at the other end. So be either open or closed-ended. So the axial force is transmitted from the pressurized oil into the frame rather than cylinder. So the two load case will be represent, so that is biaxial stress state of closed cylinder such as a boiler tank, while unaxial state of stress is open vessel such as a pipe. Open-ended is essentially a pipe, so a closed-ended for the pressurized in the cylinder can contain a pressurized fluid produced by oil under pressure. So end internal pressure will keep the skin stable and the end makes the stress biaxial, consisting of hook and tensile stress from the end. So from these two case, open end condition or closed end condition, we get to see that At open-end condition, there is normal stress that act along one direction. So for closed-end condition, there is two normal stress. So that's all from me. Thank you.
The conclusion we get from the experiment, the thin cylinder went well and the experiment goal was met successfully. Theoretical strength is measured with formula to data from the experiment, which include stress and longitudinal stresses. Aside from that, we generalize Hooke's laws and Hooke's stress are used to measure the Young modulus and Poisson ratio. Thank you.